Hello and welcome back, everybody, to the third episode of Tech Life Skills with Tanmay. I hope you're all doing well. I hope you're all keeping safe. And thank you very much for joining today's live stream. Now, we've got a lot of really interesting and really exciting stuff to talk about today with our very special guest. So I don't want to take up too much of our time before we dive right in, but there is one thing that I want to say before we get started. And that is that we as humans, we love artificial intelligence technology, we love AI, and one of the reasons I believe we love AI so much is because it reminds us, and in a way it's kind of like bestowing upon technology, giving technology some of these capabilities that we have evolved to have as humans for quite literally millions of years now. And these are abilities that we take for granted most of the time. Now, there is a little bit of sort of like a legal fine print that I would put there. I don't particularly like this analogy. It's not completely accurate, but from a high level, I feel like it's accurate. And the thing is that while we do love artificial intelligence and AI technology, I feel like we often don't give nearly enough focus to the other side of the same coin, and that is the data side. Now, artificial intelligence without data is kind of like, I guess you could say, Google search, but without the internet. Or like a programmer without Stack Overflow. Or, as my mom would like to put it, it's kind of like having a TV with no Netflix subscription. And so that's why what I want to do today is explore that intersection of data and AI at the very cutting edge with our special guest for this week. Now, she is a data and AI technology enthusiast, and her name is Ritika Gunnar. She is the Vice President of Data and AI Expert Labs and Learning at IBM, and without any further ado, let's welcome Ritika. Hi, Ritika. How are you? Would you like to introduce yourself and talk a little bit about what you do?
Yes, absolutely. So first of all, I'm honored to be a guest on this show. I've been looking at you, Tanmay, over the years, and I'm really excited to be part of the show today. Let me give you a little bit of a background on myself. So you mentioned I'm a data and AI enthusiast. I've been in and around data and AI for quite some time, whether it be building our products, whether it be actually doing development in and around our products, or whether it be actually working with our clients. And so in my current role in Expert Labs and Learning, we have over 1,000 consultants that work with clients each and every day on the methodologies, the skills that they need, and the technologies to generate the outcomes for their business. And so I'm going to share a little bit of that insight today in and along our data and AI topic.
That is incredibly fascinating. Thank you very much, Ritika. Really, it's an honor to have you on the show. And to begin today, what I want to start off with is something maybe not even necessarily directly technical. We'll be getting to that in just a moment, but first of all, I want to talk a little bit more about that community behind the technology. And as we all know, diversity is very important, and there are many different, viewpoints to take a look at that importance. But I want to get your angle and your sort of thoughts as to why diversity is so important, especially within an industry like technology, and how the need for diversity is only increasing every single day thanks to the capabilities given to us by next generation technology.
Well, anytime you have a diverse set of perspectives, you generate a better outcome. Those type of conflicts, different insights, different perspectives, they generate outcomes for you that are better than you would have thought of alone, better than you would have done if you had many like-minded people or people of similar backgrounds, because that diversity generates different ideas and different perspectives. As AI becomes increasingly pervasive, it's now more important than ever to ensure that you have diversity in the teams that develop it. Think about this, especially when you're creating AI models and components that potentially have bias, whether that bias be from the data that's within it or from other aspects. It's important to have people who can really have the diverse backgrounds to be able to ensure that as you develop those AI models, as you're developing fairness in those models, that bias does not exist. And so organizations typically focus on the more obvious aspects of diversity, ethnicity, gender, age, but that also means like differences in culture, differences in background, difference in socioeconomic status. Failing to consider any one of these really impacts the population as a whole in terms of the outcomes that you're generating from AI. This is for this reason, I'm extremely passionate lately in getting involved in women in technology and women in AI. We recently commissioned a study with Morning Consult, and while we have made progress in having more diversity in AI today, we believe that 91% of people who we surveyed think that there is a positive impact from having diversity in the workplace. Only 26% of the workforce today is females, and so there's a big gap. Mm-hmm. And if you look at some of the statistics from this survey that we had, women were more likely to be women and men who were equally interested in math and sciences growing up. Men were more likely to be told that their natural fit was in and around math and hard sciences, whereas women were told that they were more likely to be able to have a talent for humanities and social sciences. And so to be able to encourage the diversity that we need to be able to have in this field, it's important to be able to show people of all backgrounds. Now I'm doing this with women in AI and women in technology, but people of all backgrounds, they need to have the confidence, the comfort, and the support to be able to enter into fields of technology, and especially my passion, AI, to be able to promote that diversity so we can generate better outcomes in our community and in our field. And it's something that I'm so passionate about on all ends, all kinds of diversity, because we will generate better tech, we will generate better AI by having these diverse perspectives.
Fascinating. I can tell just how passionate you are about this. And actually, one thing you mentioned that really strikes note for me, that's really interesting. I mean, I've been interested in sort of like the psychology behind how people view artificial intelligence technology for the longest time. And there's this pretty incredible YouTuber that I'm sure everybody's heard of. His name is, well, not his name, his YouTube name is Vsauce. And one of his videos around optical illusions actually highlights how there's a certain kind of optical illusion, and I believe it's the optical illusion of the two arrows pointing in different directions and one line looking longer than the other. That optical illusion only fools people that grew up in more urban areas, not people who grew up in more rural areas. So even quite literally just the way you were brought up gives you a whole different perspective on how to see the world. So absolutely diversity is important. And I feel like we could even look into the world of machine learning for this. I mean, if you're someone who partakes in Kaggle challenges a lot, obviously you understand the importance of diversity, because you're always going to want an ensemble of models if you want to win a competition, and those models have to have different kinds of architecture, so you're extracting different kinds of features, so you're looking at the data different ways. So yeah, this is really important, and we can look at this, again, a number of different ways to really try and understand just how important it is. You mentioned there are some more obvious sort of variables that we look at, but there's even more like intrinsic diversity that we want within our workplace and within our communities. And really specifically, I mean, in your career over the past couple of years, have you seen any instances firsthand where diversity has helped actually produce that better outcome? Can we take a look at some examples?
Absolutely. I told you my background has been in building products, doing the actual development of them. And when we were creating tooling for data scientists in our Watson portfolio, one of the things that we looked at is like a lot of the people who were generating the tooling were data scientists themselves, and they had the background in statistics and math and coding to be able to create a platform for existing data scientists. But as we all know, that there is a big market for citizen data scientists, and that means someone who may not have that background in complete data science and complete mathematics and complete statistics and citizen data sciences enough to be able to get their job done. That requires a different perspective. And so we actually had a team of not just data scientists, not just people who understand how to build products, but we had people of different backgrounds that had either philosophy degrees or English degrees or completely different backgrounds, because if you were trying to build something for the citizen analyst, then you needed to make sure that the tooling was easy enough for people who may not have had those deep skills, as well as something that eventually could surface those who were the deep data scientists. And when you cover something that has that spectrum, you need to have constituents who are developing the products with those kind of backgrounds. And so that's just one of the examples where the diversity in the backgrounds created an extremely good product that was able to be used by citizens and subject matter experts alike. And that's what we need more of in this world where the demand for data scientists far exceeds the supply that exists out there, how are we going to generate more? You need to be able to have tooling and capabilities that's able to do that.
That is absolutely fascinating. And you're right, what we're doing is we're democratizing the sort of AI data science capability by doing this. And the only way you can do that, obviously, is by having a diverse group of people actually working on building out that software, building out that tooling. And this is really important because more and more people need to start getting into this world of data science, because we have all this data and all this compute power that's just sort of sitting here, and we need people to come and put the two together and actually start to comprehend that data, really extract the insights that we want to extract. And speaking of extracting insight, there is one problem that the entire world is facing right now, right? Obviously, and that problem is COVID-19. It's really an issue that we have to solve as quickly as possible if we want to return to some sense of normalcy and save as many lives as possible. And to do that, obviously, we want to leverage the power of data and AI, and we want everybody to have their own we want everybody to have the infrastructure, the tooling required to be able to contribute to this. And so on our last episode of Tech Life Skills with Tanmay, with Sumit Gupta, we had a little discussion on how artificial intelligence is impacting this COVID-19 response. We talked a little bit about drug discovery and how that's being accelerated with the power of machine learning. But the thing is, we didn't really talk much about data. Now, I know that data and AI, again, two sides of the same coin, but still, if you could give us a little bit more perspective on either of those sides towards how has it really impacted and benefited COVID-19 response, I would love to hear that.
Well, I'm going to take a step back and talk a little bit about, like, in the world of COVID-19, everything has changed. There's a lot more uncertainty when it comes to the citizens and the community in terms of how governments and hospitals are responding, in terms of how commercial entities are actually responding, regardless of whether you're in banking or in retail. Like, your business is changing. Every business is changing. And they're changing in a way that the vast amounts of data that they have and the information that they have also changes day to day. And so there are a few different areas where we're seeing increasing demand based on data. And let me go through that, and then I'll go through kind of the technology undercurrents that we see because of that. So first, customer experience. There's an extreme change in how customers perceive things. Again, whether you're a citizen, whether you're in a commercial entity, whether you're in a government entity, your end constituents are experiencing things much differently. And that creates a greater demand for information as that information is changing. I'll go through some solutions that we're working on there. The second is there's a lot of operational risk that every company is experiencing. If you look at all the work from home elements, this introduces new cybersecurity risks due to remote workforces, privacy threats, increased risk of loss for failure of internal controls being followed, and a lot of organizations are worried about that. There's also what it means to kind of reduce your operating expense in this time of COVID and maximize your efficiency. So let me go back to like some of the things that we're doing with data. And I think what you see with these things is, one, we want to be able to address with all the data that exists there, customized solutions for particular entities for their constituents. And so one of the things that we put a lot of effort on with Watson is our citizen assistant, which is able to work with a number of hospitals, a number of government entities. And what we're able to do is to take the plethora of data that they have, and they're changing data that happens every day because the regulations of where people are allowed to go, how their communities are opening up now. But even a couple months ago, it was like, where can you go get tested? What are the symptoms? These questions that your community is asking is changing every day. And at the same time, a lot of your workforce is remote. So the people who used to answer questions in the call center are now either working from home or you have a lot fewer of them. So we've seen a greater demand for assistant type technologies that leverage all that data and be able to service the community. And these are AI assisted solutions in the public cloud, scalable, and allow these people who are working in the call centers or working in the hospitals as nurses to be able to do what they do best. And we're seeing that not only for the healthcare workers, like in hospitals, not only for the governments, like with what their regulations are, also with other entities like financial institutions that have the small business loans. And we have a number of examples there. The second thing we're seeing is a use of a lot of artificial intelligence or analytics in and around data to really understand the problem. One of the things that we're doing is helping a lot of agencies using CDC data, using data from healthcare agencies, from a number of other entities to be able to create dashboarding to understand the dynamics in terms of what it means on the spread for COVID-19. And of course, with all the questions that are out there around creating better drug therapies, figuring out how to have the right antibody tests, there is a set of initiatives that a consortium has come together to be able to provide the right solution. So our COVID-19, I think this is what Sumit talked to you about, our high performance computing consortium, which has 37 particular members, has aggregated a lot of our computing capabilities. I think it's like 41,000 GPUs across like 36 active projects. Wow. To really fight extensively some of the research areas like bioinformatics, epidemiology, molecular modeling. And so that is the power of having a consortium of multiple companies coming together, putting their compute power together, and helping with the federal government, with many industries and academia to solve these problems. This is where, like, you take examples of the past three that I talked about. I'm so proud not only to be at IBM, but to be working in a technology area like AI, because these are the kinds of problems we're able to tackle with technology.
Wow, that is amazing. And I mean, especially the first thing that you mentioned, or not necessarily the first, towards the middle of your examples, you mentioned how there's this greater demand of, for example, assistant type technology, since we simply don't have the human infrastructure to actually handle the vast amount of calls that are coming or the questions that are being asked. I mean, this is really showing us that there are better places for humans to be working, and there are more valuable industries for us to work within, and that we should be taking these sort of redundant, repetitive jobs that don't require our human intellect or creativity, and sort of be augmenting ourselves with artificial intelligence in these fields, enabling us to work in fields that do require these special capabilities of ours. And I mean, we talked a lot about data here, right? And these were great examples. But then there's always these issues whenever it comes to these new technologies, and there are issues that, of course, make sense. Like, for example, privacy. People want to make sure that, while we're capturing data and while we're leveraging it to its fullest extent with artificial intelligence, they want to make sure their privacy is kept intact. And we've seen applications like, for example, contact tracing through phones. So if two phones come in close proximity of each other, and one of them, the owner, was diagnosed with COVID-19, the phones can actually help out with contact tracing. But this is a feature that not a lot of people have actually enabled on their devices. I mean, at least I know, for example, in Singapore, they haven't reached the 60% threshold that they need to make it actually useful. And so what are your thoughts on that privacy aspect? How can we balance that trade-off? And in a time like this one especially, do you think people should be a little bit more open or less open with their data? What are your thoughts around that?
I wouldn't tell people what to do, because it's their own personal perspective on what they do with their data and how comfortable they feel. But definitely, I think companies need to realize in this time, and this is something that IBM has been vested in for decades, is, when you're talking about particular workloads that are enterprise workloads, you need to make sure you have the right privacy and the right constraints in and around how data is actually being used. There may be other applications that are used for citizens or other things where it may be more comfortable, where you don't have those concerns. But where you do, we think it's really important, like especially in areas like GDPR, the California Consumer Privacy Act, there are needs in certain types of applications to make sure that you have the right data isolation. We're seeing a lot of that, especially as workloads are moving more to the public cloud. How is my data being isolated from other data that exists? How are you anonymizing particular data? And maybe anonymization is not enough. You have to do things like pseudo-anonymization, which is, you want to be able to not only tell that it's not from, Bob, but you don't want that category to even, that de-identification procedure needs to be so good that you cannot identify any fields within that data record. And it becomes even more important in the cases like AI, and I am really proud of what IBM does here, where you need to be able to have trust that the models that you're building won't be shared with other people. The data won't be shared. Your data is your data. Your models are your models. And that you have the ability to be able to trust that when a model makes a certain prediction, how that prediction was made, and that there are no biases in there. Now, that's an area where I'm going to go into a little bit later, but it is an area where I think is extremely important to know that you can have trust in the type of AI and the data from which that AI was built. And we are going to see a lot more of that going forward.
Wonderful, wonderful. Thank you for sharing. And also, quick note before we continue, let's pause for just a moment. I do see we're getting a few questions to the live stream. That's great. If you have any questions, feel free to put it in the live chat on any of these social media, YouTube, Facebook, Twitter. We will try to get to as many questions as we can towards the end of the discussion. But yes, thank you very much, BQ, for your question. We'll get to that in just a moment. But first of all, I want to get another one of your thoughts here, Ritika. And now I want to sort of transition over. We talked a little bit about sort of the impact of data on COVID-19. We've talked about, some issues like privacy and bias. But let's sort of dive deeper maybe into those areas. And I mean, there's a lot of really fascinating stuff happening in terms of research and artificial intelligence right now. Some of the things that excite me a lot are like, for example, say hardware accelerated artificial intelligence technology. We're seeing hardware like IBM Research has their new analog AI chips, right? We're seeing NVIDIA just a little while ago release their brand new Ampere architecture with that fascinating new Tensor core that supports 32-bit inputs. That's amazing stuff. And so there's a lot of stuff happening in research. I've just talked about this one example. What are some of the most exciting innovations in the data and AI space that you see coming out of research? And how do you think they're going to impact not only, I mean, first of all, the academic sort of field of AI research, but then from there, how will it impact society and how will we benefit from them in the future?
Yeah, I'll go into three particular areas that I'm really interested that the research team is doing. And I think when you subsequently have some of our research people on, they can go into the deeper technology components of this. But there are three areas that I think are going to make a big impact to society as a whole, to our product portfolio as a whole. And I'll go into that. The first one is auto AI. And the way I think about this one is if you look at the definition of artificial intelligence, it is the intersection of coding and programming, math and statistics, and data. And anytime we have in history where you have an excess of demand of capabilities like AI, you figure out how to have some sort of automation. And we're seeing auto AI capabilities come out. When you look at that definition, it's easier to think about automating the coding and the math and statistics. Data is always something that organizations need to be able to have, or that needs to be able to be there so that the subject matter expert capabilities are there to be able to train the AI capabilities. And so, of course, there's a lot of work that we're doing in the auto AI capabilities, some of those that are already out in products, and some of those that are going to be continually coming. Of course, you may know, of course, of our neural network synthesis capabilities that uses a series of techniques of coarse-grained and fine-grained synthesis to generate models for things like natural language programming, and it's expanding quite rapidly. But I think auto AI is definitely one of the areas where I'm most interested in seeing how technology progresses, because it takes the AI capabilities and allows more for that citizen data scientist over time. The second area is really around trust and transparency, or what it means to really have bias detection and mitigation and explainability of models. This, and talking to many organizations, is probably one of the biggest things we see as an inhibitor for enterprises really putting AI into their production areas at scale. You know, we see organizations that have hundreds of data scientists that build out thousands of different models, and when we ask them, how many do you have in production? It's usually less than a handful. And so to be able to get that less than a handful to be thousands, you need to be able to give and empower a lot of these organizations the ability to explain how the AI model came to a decision, and if there's a bias in that model, to be able to evaluate that bias and then to de-bias it. And so there's a lot of work that we're doing there. There's some technology in Watson OpenScale. I think this is going to be the next thing that we really need to be able to get AI out there at scale. And the third area is really what we're doing to progress natural language programming. If you think about it, you know, we've made a lot of progress in natural language programming, but this problem is far from being solved. The computer is still not capable of holding free-form conversation with a human being on any topic without a lot of training. And of course, many of you have seen what we've done with a lot of our research capabilities in Project Debater, this really kind of takes it from, okay, there's natural language processing to do Q&A, there's natural language processing to have conversational analysis, and then what you need to be able to have like argumentative conversations of really kind of debating and having those kinds of things. And so, what this really embarks on is challenges in data availability, customization needs, system requirements. And the way our researchers break out NLP is really in 4 particular areas. Can you understand? Can you classify? Can you retrieve? And can you generate? Given time, I can go into that in more details maybe in the Q&A, but like we really need all 4 of those to continually progress. And this is what our research teams are working on with Debater. And the innovations that I'm most proud of that the Debater team has kind of done is really like speech, writing, and delivery, listening comprehension for long, contiguous sections of speech, and the ability to be able to model human dilemmas. These are really important and will continue to progress natural language processing. So those 3 things, auto AI, trust and explainability, and what you do in natural language processing, I think these 3 things are really going to progress the field of AI.
That is incredible. And just sort of to elaborate on one thing that you mentioned there, another question that I have. You already talked a little bit about natural language and how natural language processing, while we have made strides in this field, we're definitely nowhere near where we want to be. And in my opinion, what really makes modern machine learning, and this includes deep learning technology, what makes this technology so useful, so incredible today, is the fact that we can start to understand not only tabular and structured data, but also unstructured data like natural language, like visual data, like auditory data. And so I want to get your opinion, sort of to dive a little bit deeper into this, on what kinds of data, what kinds of unstructured data are we not leveraging to its fullest extent today? And where do you see that going in the future? How can we start to leverage that data?
Oh, well, there's all types of unstructured data, but if you really look at it, we have a plethora of document data that exists here from like decades of unstructured document data, whether that be, invoices, text, litigation, laws. And it's an area where we believe, like, if you were to be able to take that corpus of data and really drive value from it, that takes you far forward in terms of training to be able to answer kind of these long, like question and answer writing form kind of capabilities. So it's an area where we've also, our research teams, when we go deeper into this, are doing a lot of work on smart document understanding. How do you start having a view of truly understanding every document, because every document has different structure, different canonical syntaxes, different intents. And so that piece, I think, will take us quite far.
Perfect. That makes a lot of sense. And yeah, you're right. There's a lot of untapped insight within that document, within that natural language data. And I do want to see how we can start to leverage that data in the future and start making use of it. And so now let's transition over from research. We've talked about artificial intelligence technology. We've talked about sort of what we're going to be doing with it in the future. Next, I want to talk a little bit about how technology should be built. And specifically, I want to talk a little bit about the ways that people should be sort of educating themselves about technology and how you should go from beginning to end with a certain technology-based product. And I mean, a question that I get asked a lot, for example, is like, how do I get into the world of code, right? Or how can my child learn how to code, or things like this. And usually my response would be that before you can learn how to code, or before someone can learn how to code, you've got to differentiate between that, programming language and just the syntax of a language versus that computational thinking and problem-solving framework that you build in your mind that is then used to actually take a problem and translate that into what the computer is capable of doing, individual steps to solve that problem so that you can go ahead and implement it, right? Learning a programming language is easy, programming is easy, that computational thinking is what the difficult part is. And so what do you think, what are your thoughts on that? First of all, what's an effective way of going about building that problem-solving framework? But then from there, once you have that, what's a good way of going about applying that problem-solving framework to actually build useful technology solutions, at least from your experience in your career?
So I'll give you, so I always believe it's not the technology itself, it's the application of the technology. It really is kind of that problem solving. I was actually not an IBM thought here, but I was talking to my neighbor who was really giving me a piece of advice that it isn't about math and science. You don't really care if your kids learn algebra, calculus. You really want them to learn how to think for themselves, how to dissect a problem. Because if you can teach your children, or if you can teach yourself how to really take the most complex problems, dissect them into something simple, and then reconstruct the answer, you've taught them a skill that they can use regardless of framework, regardless of programming language, regardless of what they do in the future. So let me extrapolate that to the business sense on the things that I work on every day. I always talk about outcomes that you want to generate for your customer or for yourself really are three elements. The first element is the technology, but that alone will never make it successful. It is about having the right kind of methodologies and the right kind of expertise beside it. The expertise is the decades of types of experience that you've either had before or what you've done in case study mode to realize what works and doesn't work. And that kind of understanding is extremely important, along with then the methodologies that help you accelerate that over time. So I always think outcomes are equal to technology plus methodologies plus your expertise. Your expertise is something that either you've accumulated over the years, or by seeing how others have done it, you have a way of really accelerating and learning that logical thinking framework. And I think that's so important to apply in everything you do, whether you're a student right now who is learning how to code, whether you are in the business and trying to be able to come out with your own project, or you're doing that for many customers. Having that framework of understanding, okay, what is the problem I'm trying to solve? What are the ways in which I'm going to do that? And how is the technology going to facilitate that? It's probably one of the most important frameworks.
Incredible. So that, again, that makes a lot of sense. You want to take a look at it from end to end, right? You don't just want to be taking a look at one specific component. That you really want to have that problem solving framework in your mind that is generic across domains, and then within those domains across individual fields, right? So like within programming, across programming languages, but then really you can apply that framework to any other field. It could be language, it could be science, it could be whatever else. You should still be able to apply that how to think framework. And now, finally, we've been talking a little bit about sort of technology, education, and the right way to build tech. And developers obviously are very excited to incorporate artificial intelligence and machine learning capabilities in their apps. And obviously, AI machine learning, that's a very important capability to include within your applications. And so my question for you is, how should developers who may not have as much experience with AI or machine learning, how should they go about actually implementing that tech in their applications? Now, if you take a look, there are a lot of different ways to do it, right? And there's a lot of different ways that even a single company could market it. Like, for example, IBM, right? They've got, we got the Watson catalog services. IBM has their other cognitive APIs like IBM Visual Insights under the Power AI banner. You could use Watson Machine Learning, which is technically one of the catalog services to train a model with code, or you could go through Watson Studio, or you could actually rent out like an actual virtual machine or a bare metal on IBM Cloud and then do things yourself. There's so many different things you can do. How would you recommend that developers go about incorporating intelligence capabilities into their apps?
It's a good question. I would say, first of all, get started immediately with what you have accessible. I would recommend the IBM.com public cloud and using a lot of the services that are there, because it allows you to be able to start getting results immediately. And that's one of the most important things as a developer. You want to be able to get started with your services, integrate them into your existing applications, and start to play around with it. I think one of the most important things, regardless of which way you do it, is just that you do it. Get started. And I think there are probably three things that I've learned. They all start with C. So this is going to be a little bit of I'll kind of walk through my three C's. The first one is developers who may be new to AI, get the confidence. And the confidence comes from, in my opinion, the second thing, which is develop a community or an area where you can have practitioners that help each other. This is probably one of the most important things that I think is important to be able to progress, not just developers in AI, but remember that first topic we talked about, diversity in AI. having a community of people who can actually help you, support you, and give you the confidence you need to get started, I think is really important. The second thing is be continuously curious in your learning. You should know this better than anyone, but the average skills today that exist in technology last for 24 to 36 months, and AI is 12 to 18 months. So the tech that you're learning today is probably going to be different than what it is 18 months later. So again, it goes back to that discussion we just had, that the most important thing is understanding how to problem solve, understanding and putting a framework for how to solve those problems, because the languages may change, the frameworks may change, the technologies may improve, and you need to be able to stay on top of that, but still have the ability to deconstructing. So I would say get started, and it's all about confidence, community, and having that continuous and curious learning.
Nice. So it's confidence, community, and continuous learning, and that curiosity. That is amazing. I love those 3 C's. That's definitely something that we're going to highlight from today's episode. And so those are the questions that I wanted to ask you personally. That was really insightful. Thank you very much. And now I feel like it would be great if we could transition to the many questions that are coming through our live stream. Lots of people are very curious about all sorts of stuff that we talked about today. But there's one question that I want to start with. And this is from BQ. Thank you for asking this on YouTube. And I'm going to actually focus on the ending part of his question. And that is, how important is the human element in production based off of the insights gained through artificial intelligence? So the human element in production based off of the insights from artificial intelligence. How important is that?
I think it's extremely important. I mean, this goes back to when you look at the difference of, I'll give you an example. When you have a model that determines whether someone can get a bank loan or not, when a human does that, a human may have some room for error and it may be okay. When you're doing that with AI, your accuracy, your explainability of what went into how you made a decision for that, your biases are not as tolerated to be able to have the same tolerance level that you would if you were a human. So the human elements become really important in how you train, but I would say the tolerance level for having the same, I'm going to say, the same fallacies in how you make that decision are not tolerated in AI, like they are tolerated as humans make those decisions.
Mm-hmm. Interesting. So yeah, the human element is important, but as you mentioned, it kind of depends on the use case, right? So there are some that are really important. Personally, one of the examples that I always take would be like healthcare, right? In healthcare, it's very important to have that human element, but it really does depend. So from there, let's see. We are getting a few interesting questions on one specific topic on AI, and we'll get to that in just a moment. Let me just quickly see if there is another question. Okay, so another question from BQ actually on YouTube. How sophisticated is artificial intelligence in contextualizing or interpreting what it learns through natural language processing?
How sophisticated is it? Well, we've gotten fairly sophisticated. It's just there's a long way to be able to go. And this kind of goes back to that human element. I'm going to go back to BQ's human element question because I was thinking about it a little bit more. We've gotten sophisticated in the way where we can actually train assistants, as an example, to answer questions and answers in a very human element way. We've gotten sophisticated enough to where we can even make it conversational. We can add elements of a personality in the response that we give back. We can add elements of understanding empathy and being able to give empathy back. But then, as you see all the progress that we've made in Debater and really understanding long contextual pieces and being able to give an argumentative position, those are things where the world still has a lot of progress to make. And of course, we're putting a lot of investments in that because that's like the next stage of it. So a lot of progress, not only on the technology, but those human elements. BQ, since you brought that up in your earlier question, but there's still a lot of ways to go. And I do think that's the next frontier that we'll start to be able to see. When you can naturally start having argumentative positions, really understanding, extremely conversational, long dialogues with artificial intelligence, that's, I think, the next wave.
Right. Being able to understand that context across large time spans, that is absolutely an interesting challenge. We have seen a lot of sort of research being done. I mean, as you mentioned, this Project Debater. Facebook recently came up with their brand new neural network architecture around more natural conversations through sequence-to-sequence type recurrent neural networks, as far as I remember. I haven't taken too much of a look into that research, but that's definitely something I'm interested in. Now we are getting a very popular question, actually. Lots of people are asking similar questions to this. But the first one to really ask it in a single form was Sarthak. And he says, and I definitely have some really strong views, but first I want to hear it from you, Ritika, is how can we make sure that AI won't make the world just like the Matrix, where machines control the world and humans? After all, AI can also think for itself as well. So what do you have to say about that?
Well, this is where the trust and transparency components come into it, right? Look, I want to go back to the first statement you made at the opening comments of this program, and that was, to be able to have good AI, you need to be able to have good data. You cannot have good artificial intelligence without a really strong information architecture. And as part of that information architecture, a big part of that is the whole AI lifecycle in itself. AI is a living, breathing thing when you think about it, as it learns more from the data it sees. AI itself becomes smarter. As part of that, you need to make sure that the AI components have a loop where you're therefore actually understanding what data it's now exposed to. You're continually checking biases that exist in your algorithms. You're continuously checking the data that it has been exposed to. And this is where I go back to, when you talk about the handful of AI models that are in production in enterprises and what it means to get thousands of them in there, it is about providing that production view of how you put AI into true applications and how you're managing and monitoring that in a way where you understand the data. You still have to understand the data and the different components that go into it. What's your perspective, Tanmay?
So, I mean, one thing that I want to take a look at really is sort of talking about the second part of the question specifically. The second part of the question talked a little bit about how artificial intelligence can think for itself, and I feel like, I've done quite a bit of research into into sort of the psychology, again, as I was mentioning, around artificial intelligence and sort of why people view it the way that they do. And I feel like there's the thing that I've noticed is that, like, for example, on your Apple Watch, it does fall detection, right? So if I were to take a fall right now, my Apple Watch would detect that, and it would be like, hey, you fell. Should we call emergency services? And the Apple Watch does that through machine learning. It's analyzing the data through the accelerometer and the gyroscope, and it's using machine learning technology to relate that data to, did the person fall or not? But the thing is, when we take fundamentally the same mathematics, right? There's nothing fundamentally different from an idea or from a theoretical perspective. When we take that same fundamental math and we put it onto a different form, like a chatbot or a humanoid robot or things like this, people start to view it as intelligent, and people start to view it as something that can think for itself. And I mean, what you mentioned, you gave a little bit of an analogy saying that AI in a way is like a living, breathing system that continuously adapts to data. I do agree with that analogy, but I feel like we should be careful with wording, because when we say things like a living, breathing system, that kind of has like a double meaning to it, right? Because a lot of people could either take that as it's a system that adapts to the new data that's fed into it, or you could take it as it's in a way alive like a human, right? So there are many different ways you can take that, and it doesn't seem like a lot on the surface, but when you take a look at like the linguistic psychology behind that, the way that the brain actually represents language, you start to see just why people are so confused about this. So I don't want to go into too much detail, because then that's going to be like the next 10 minutes just talking about why people view AI the way they do. But in general, I would say that it's our subconscious that is really tricking us into thinking that artificial intelligence is more intelligent than it really is, whereas at the end of the day, it's just mathematics trying to correlate X to Y. And so I feel like we should be taking a look at it from that angle and not from the angle of AI is intelligent, because it isn't, right? So anything else you wanted to add there, or should we move on to our next question?
No, I thought that was great. That was great.
Thank you. All right, perfect. So we see another question from Rohit on YouTube. He says, What is the future of microservices and DevOps? Will we see the rise of FPGA and RISC-V development?
FPGAs and RISC what development?
RISC-Vs. I think it's an open source reduced instruction set computer architecture.
Okay. I don't know about that particularly, but I'll tell you what I do think about microservices and DevOps. I do think that's a big part of I think that intersection with operations of AI in production environments are intersecting. It is one of the areas where we're spending a lot of our investment in really understanding. I think there's a couple things that are going to happen. Microservices architectures are here. They are here to stay for a while. And when you think about DevOps processes and how you actually manage applications today in production, those DevOps processes are going to have to change as you put more artificial intelligence into those applications. So I'll take a step back and say AI is not necessarily living, breathing, but AI adapts to the data it sees, as you mentioned. And because you now have AI that's adapting to the data as it sees it, which is part of a greater application, your DevOps processes also have to change as well, because you need to be able to have the same production controls on that changing AI component because of the data for that entire application. So it does introduce a lot of additional skills that are necessary in that whole DevOps process, because the person who is now managing a production application that didn't have artificial intelligence now needs to know what and how does their role change, because they are now managing an application that has predictive models as part of it. Those predictive models may be changing because of the data that it's seeing, or may have change control on the model itself as you change that. So we will see, I think, a big transformation in this place, and we're already starting to see this with a lot of customers today, in that having a operations for AI lifecycle management is absolutely critical.
Interesting. So thanks for your perspective on the first part of that. I think I can also touch a little bit upon the second part of your question. So I just searched up RISC-V just to make sure I was thinking about the right thing, and indeed it was an open source instruction set for and CPU architecture. And in my opinion, FPGAs, they will definitely become more popular, but I think it would be for very specific use cases. And like, for example, with artificial intelligence, I don't think FPGAs currently will be particularly popular for training machine learning models, because we've already got things like tensor cores and NVIDIA GPUs, things like that. Yeah, exactly. Which are great for training. For inference, however, they can be very, very fine-tuned for specifically your architecture directly on the silicon. So FPGAs for very specific use cases, yes, they will be popular in my opinion. For the rest, it's going to be ASICs, right? So like, for example, on your phone, you want an ASIC for a neural engine, not an FPGA. You don't want an FPGA in a phone. But then from there, RISC-V, your question around that, I do think RISC-V is going to be growing in the future. I don't think it's going to be very fast because of, I mean, again, the fact that while it is open source and while that's its main advantage, in a way, I feel like that's also one thing that wouldn't let it grow as quickly, because a CPU architecture generally is something that takes way too much, infrastructure and backing and support to really grow and expand and get a community behind. However, the advantages that an open source instruction set would give you are great. Like, for example, if you take a look at Raptor Computing Systems, part of the Open Power Alliance at IBM, they have these like completely open source computing systems. Like, for example, the firmware on their motherboards is open source, everything is open source, enabling anybody to modify any component of anything on their systems whenever they want to. And the impact of that is that people trust those systems more than systems developed by actual companies meant to develop for enterprises. So trust is a huge part of that. And again, I do think RISC-V will grow in the future. I just don't think it's going to happen very quickly, because of the fact that it's open source, and because of the fact that there isn't enough backing behind it to get things, or to get major software to support it as quickly as it should. So unfortunately, as with a lot of things, even though the technical angle it might be superior, because of a lot of other factors, it may not grow as quickly as we would want it to. Right. And so now we have another really interesting question from Akash Gupta for you, Ritika, and that is, how important is domain expertise along with AI in the industry? Can artificial intelligence do that also to some extent?
I think potentially over time, if you have models that are trained in particular domains, you may see that. But domain, like remember, go back to the definition that I talked about of, it's the intersection of programming, math, and statistics, and then the data domain. The data domain needs to come from somewhere. If the data domain is already pre-coded somewhere in existing models and you're using a mesh of different models to be able to drive some of that domain, that's okay. But in most of the cases where we see enterprises creating models that are specific to their subject matter expertise and to the way they run their business, somebody needs to be involved to understand the domain in which you're actually programming. And in fact, that's where, like, when I think about the biggest challenges in getting AI projects adopted, it isn't the technology. I always talk about there are 3 inhibitors to how to drive AI projects at scale in any organization. The first one is data. And we've talked about that. You need to be able to have data. You need to be able to have enough of it. If you have it already pre-coded in some of your models, that's fine, but you need to be able to have an understanding of the domain of data. The second is the process. And, we talk about, because AI is changing based on the data that it sees, and because AI itself is not good enough alone, it needs to be part of an existing process or an existing application. Having an understanding of the full end-to-end process and the outcomes it's trying to drive is the second thing. The third is the cultural aspects. And I think cultural aspects are often underestimated, because if you think about, you need to have an understanding of the data, and you have to have a subject matter expert that understands the data. You need to have an understanding of the process or the application and how you're going to change that. That means the culture of an organization needs to change. And that needs to happen not only top down, but also bottom up, because everybody's job is going to be changing because of artificial intelligence. Sally, who was the data analyst before, needs to be involved in being able to create these new AI models, because it isn't just by having a data scientist you're not going to be successful. It really requires, I think, breaking down the silos that exist between the lines of business in organizations. And so I always say culture, process, data. Those are the 3 ingredients that often get underestimated when creating AI projects.
Culture, process, and data. Again, another great highlight from today's episode. I mean, what you mentioned towards the end around breaking up those silos, I remember I had a talk a little while ago. I'm forgetting what the conference name was, but it was somewhere in Chicago. It was actually, I believe I'm forgetting when it was, or what the conference name was, but it was a talk in Chicago, and there were a bunch of business leaders at the event. And the main question that a lot of people had was, how can businesses adapt to artificial intelligence? And yes, I remember the conference name was IT Synergy. And really what my sort of main response to that was again, you have to break down the gap between the developers and the people who understand the technology and the domain experts that understand where that technology will be applied. Because when you have those 2 people working together, again, as you mentioned towards the beginning, Ritika, when you have that sort of end-to-end process, that's when you get a truly meaningful user experience. We have a sort of more of a... We talked a little bit more about that in the very first episode of Tech Life Skills with Tanmay, actually with Dave Mukherjee, around how those user experiences can be developed. So that is absolutely fascinating, and thank you for your thoughts on that. Next up, we have a lot of interesting questions. I'm wondering which one we should get into next. People are talking about risk architectures. People are talking about blockchain. Do you have any experience with blockchain technology, Ritika?
There are a lot of capabilities that we've done in intersecting blockchain and AI, because if you look at it, having the blockchain itself is one aspect of it, but we're using AI with blockchain either in food supply or in what we're doing in the consortiums with the multiple different banks. So yes, there are multiple examples that we're driving in that, but I'm probably not the best to be able to talk about the technical architectures in and around underneath there.
That makes total sense. Right, so we're getting another question. This one's really interesting. You can talk a little bit maybe more about sort of what's coming out of research on this one. How can artificial intelligence learn to develop new artificial intelligence algorithms?
So this is AI developing AI. I think it's one of the things where we're going to see this a lot more, even in a lot of the AI products that are coming out. If you think about it, the ability to be able to create, I talked about the neural network synthesis capabilities. There's ton of models out there. And this is one of the things you talked about, Kaggle competitions. There are a ton of algorithms and deep neural networks that are out there. And one of the things that our neural network synthesis capabilities does is it uses two sets of synthesis to be able to create and auto-generate some of the AI capabilities. Now, I'll tell you this at like a high level, but this is one where you would have to get one of our research members like Ruchir or Sriram to be able to talk about that in more detail. They would give you the real innings on it. But the basic idea is we have an idea of all the deep neural networks that we've seen before and all like the concepts where we understand and have a history of how neural networks have been used in the past. As you generate new AI models, you want to be able to generate the nodes and all the interconnections in between those nodes. We have a set of capabilities where you can generate an initial set of nodes and an initial set of connections of those nodes in a deep neural network using a technique that we called coarse-grained synthesis. And then the ability to then go another level deeper and take any n number of maturations on those connectivity points between the different nodes, and that is called fine-grained synthesis. You take these two elements together, and we can develop the same kind of neural network synthesis, neural networks that you would generate in Kaggle competitions. Those that may take months for teams to create, we can create in hours or days. And so using those kind of similar techniques. So that's a very high level at how some of that works. I would suggest, like, if you have someone like Ruchir on at some point, he would be able to go into the details of what that technology is and how that's really transforming. There are also other techniques. Now, what I talked about was just for neural networks. There are also other techniques that we're using for generating auto AI capabilities in terms of just changing different components of a particular model itself and then retrying it and seeing which one has the best fit for a particular problem. So there are multiple techniques that can be used, some of them for more complex types of problems, some of them for just retrofitting and finding like the best performance of an existing model. Those are just a couple of examples of what we're doing in our technology today.
Incredible. So yeah, absolutely. You talked about a couple of things that are coming out of research. You mentioned that Ruchir and Sriram would be able to go into more depth. We actually, a little bit, in case anybody on the live stream knows about the Tech Time with Tanmay series that I was hosting, when we could actually do this in person before the whole COVID-19 lockdown stuff, we were actually planning on having Ruchir and Sriram as the two next guests after, but unfortunately that's been delayed a little bit due to this whole situation. But we will have them on soon to expand and elaborate even more upon your questions around auto AI, auto ML. Now, we are getting another question. This one is really fascinating to me, and I want to see if you have any thoughts on this. What programming languages are the best for artificial intelligence or machine learning development? Not just for the future, but also for, not just for the present, but also for the future. And this question is from NB575.
So programming languages. Look, I think there are a variety of programming languages, and I'm going to say frameworks out there. I mean, you're probably maybe more apropos to be able to answer some of these. Like, we have teams that are doing like TensorFlow, PyTorch. Any kind of framework, I think, is for the moment is probably reasonable to be able to get started. In terms of determining which one is probably going to be the future, I think it depends on the kind of workload and what you're actually programming and what the workload actually is and the intersection in which it fits into. So that answer, I think, varies depending on the workload and depending on the type of applications that you're actually developing. What are your thoughts there?
That makes a lot of sense, and this is actually an area that I've been working in for like the past year and a half or so. And in my opinion, really, programming languages, if you think about it, are of course, they're the main tool that developers use in their day-to-day lives, right? They are the infrastructure behind everything a developer does. And so when you have a programming language, a framework, and a compiler that are all working towards helping the programmer as much as possible and not drawing back, then you have more efficient code that can be written faster with fewer bugs. And that's why I have specifically been interested in the future of where this is going to enable developers to write better code. And the two languages I see at the forefront of this are Swift and Julia. And the reason I say that are because the compilers behind those languages were built keeping artificial intelligence technology in mind. I mean, if you take a look at Julia, especially, they literally built the entire language with the sole purpose of how can we accelerate scientific computing with a better compiler that can be programmed directly from within the language. You can quite literally write CUDA kernels in pure Julia with no C involved, right? So you can do essentially anything in pure Julia without any C involved whatsoever. I mean, NB755, 575. You mentioned that Tanmay wrote a book on Julia. Why isn't he using it? Well, I did write a book on the Julia language, yes, and I do use Julia, but remember, you also have to think about community. You've got to think about the frameworks that already exist and the workloads that you're trying to run on them. For some very specific, extremely intense workloads, Julia is perfect, but then you're not always in that intense area. You're usually more towards the middle and the low end of that spectrum, which is why I'm so passionate about Swift, because it has an LLVM-based compiler. And with LLVM, what that means is that you can now actually, from within the compiler itself, take a look at all different sorts of tensor operations, extract a tensor graph out of the actual application so you can write dynamic code that is then compiled to a static graph and then used automatically by the language. So there's a lot of really interesting stuff that's happening there, enabling developers to write simpler code that ends up running faster and has a smaller surface area for bugs, all thanks to the fact, and it's even easier to comprehend, all thanks to the fact that, hey, now we're using a compiler and a language that were actually meant for this, like Swift, and not something like Python, which is just kind of bootstrapped on through a C interoperability sort of layer. So that's definitely my favorite set of frameworks and languages, and that's something that I've been working on for some time now, and hopefully more people start to adapt to these new languages soon.
I think that goes back though to it's fit for purpose on your workloads, because even
Yes.
Swift is only available, and even that LLVM kind of framework only works for certain types of applications. I think even Julia, you're right, it's only for that specific type of workload. So it really is dependent on what kind of outcome are you trying to generate, what are the constraints that you have in terms of the types of applications that you're trying to build, where they're supposed to run, what kind of platforms they need to be able to execute on. All of that matters.
Absolutely, you're right, and hopefully we can start to see sorts of these sorts of new languages and new frameworks that are meant for this sort of artificial intelligence technology and sort of become the new de facto. Right, so let's see here. We're getting another question. There is a question from Ravi that I will get to in a moment, but first I want to see a question from Lawrence. I think AI algorithms aren't the problem, but the biggest challenge is how companies will interpret data models. So many different cultures and cognitive learning processes. What are your thoughts on that?
I think that is absolutely true. Well, I think it goes back to, it isn't the algorithms, it's that trust and transparency element. Like, I read that question as it goes back to organizations need to be able to interpret kind of the decisions that AI is making, really understand them, really have trust in those decisions, and then only are we going to see that explosion of AI. And I think, we have to have not only the tooling, but also the training and understanding and kind of the history behind us for that to be able to have the scale that we need to be able to have. It goes back to, like, I think I've given this quote a few times. One financial company, the CTO of the company said, look, I have 1,000 flowers of AI blooming, but I have 3 in production. And, to be able to kind of get true AI, it's not the algorithm. I can develop algorithms all day long. Mm-hmm. It is about the other elements of where that algorithm fits into and how I can explain that to the constituents that need to know how I'm making that decision, how AI is making that decision. And so I do completely 100% agree with that comment.
Interesting. And I mean, next up, we have a very specific question, actually, and I want to see if you know anything about this, or maybe not, if it's not directly about this, anything around this. A question from BQ on YouTube. How is AI being used in marketing? For example, interpreting emotional data from camera feeds.
Well, not that one, and particularly on camera feeds. But look, marketing is using it in multiple different ways, whether it's product placement and where to place your products, where to actually have supply chain optimization of your product, where to actually do the advertising. It's used in almost every component within marketing and the whole marketing lifecycle. So we see uses in actually many marketing companies or every industry in their marketing departments in and around how they're actually leveraging AI to do targeted marketing campaigns in and around the right constituents. Because if you look at it, like, this is an area where even if you look at what you have yourself, you never get the same marketing campaign or advertisement that your friend does. It is really tailored to the knowledge of you. Most companies today have a really good understanding of who you are, what your preferences are, what you like, what you've even purchased based on your past purchase history, and they can actually make those recommendations. That's just a starting point. But then when you look at it, taking all that information, even data such as weather, and starting to optimize your supply chain in terms of how not only you're going to target, but what you're going to do for your inventory in and around that. I think it's the whole chain from marketing and targeting that marketing all the way down to inventory management, all the way then to how you actually deliver those goods. So throughout the whole life cycle.
Yeah, I mean, again, this gets back to what we were saying. It's end to end throughout the whole life cycle. That's what's amazing about technology, and specifically AI. It's really impacting every single part of that chain. And I mean, it's even impacting itself, right? We're using AI to build AI models, right? It's really a meta technology in the sense that we're using it literally everywhere, which is quite incredible. Let's see if we're getting any more interesting questions. Also, yeah, I mean, just to sort of elaborate on that as we get a few more questions. What you mentioned around marketing, I mean, if we take a look at like, for example, Amazon, right? When they are trying to predict what products to recommend to you, they're not only taking a look at like what products you've seen in the past or what you're taking a look at currently. They are going down to the level of where your eyes are looking on screen, right? They're able to use machine learning algorithms to predict what it is that you're looking at based off of cursor movements. And so there's all this incredible stuff that's happening. And again, also ties back to what we were talking about a little while ago. These sorts of data points and these sorts of features can only really be extracted when the people that understand the technology work with the domain experts, right? People that understand retail and the psychology behind it. That's sort of the only way you can really come to put this together. Now we're getting towards the end of today's session, so please do send any more questions you feel like you may have. But one question that's really interesting, what will be the next leap in artificial intelligence technology?
I think, look, I'm going to go back to the three things I talked about that I'm really excited about that our research teams are working on. I think the next leap is really in around natural language processing. I'll start with that. I really do think having more conversational for longer for longer periods of natural language or longer statements of natural language, and having that argumentative position point of view like what we're working on, that's going to be the next thing that I think humans actually see. Underlyingly, in terms of to be able to get it adopted at a more rapid rate, the auto AI and the trust and the explainability components become really important. But natural language processing, that is, I think, the next frontier. If you think about it, natural language in itself is really kind of like that next linguistics professor of technology. If you think about it, like NLP itself and the progression of it is that linguistic professor of tech. And we have gotten to where we're definitely out of grade school. We're definitely like, probably somewhere in middle school. And I think you're going to see that progression into adulthood at an extremely rapid rate. And I'm looking forward to that.
So am I. I mean, natural language has been something I've been passionate about for the longest time. Ever since I saw Watson playing Jeopardy, that's been like the one thing that's like most fascinating to me, having machines understand, comprehend, generate natural language information. Right, okay, so now one more thing before we go today, Ritika. First of all, thank you very much for your insights. This was really helpful. I'm very sure that the audience absolutely loved it. And one thing I do want to ask, that we've got a pretty diverse audience here. We've got people from all sorts of backgrounds, all sorts of demographics. And so is there any message that you want to leave them with before we go today?
I think there was one thing that I ended on one of the questions that you gave me on how people start learning. And to me, for anyone who's listening, you're probably either an extreme like mathematician, data scientist, and AI professional, or you may be just interested in becoming that data scientist or becoming someone who really understands or embarking in the field. I want to urge everyone who's out there to really embark in and around an understanding of AI and data science. I do believe, many people learn reading and writing and arithmetic. I believe that AI is that next frontier. And whether you decide to choose a profession in artificial intelligence or not, it's going to impact you in one way or another. So, have that curiosity of the continuous learning that I talked about, have that confidence, and build out the community to really learn and understand it. You may not take a profession in it, but it is absolutely essential to the future.
Exceptional. Thank you very much for sharing your thoughts. I really appreciate it. Thank you very much for joining us today, Ritika. It was an honor to have you on the show as a special guest. Thank you
Pleasure.
very much, everybody, for joining in today. And with that, that concludes the third episode of Tech Life Skills with Tanmay. If you have any more questions, feel free to leave them down in the comments below, and we will try to answer as many as possible after the chat. Remember, if it's in the live chat, we can't answer it, but we can if it's in the comments of the YouTube video that will be available as a recording. So please do make sure to do that. And I do see really quickly, there's one more thing I want to point out. There are lots of questions and a pretty nice discussion going on about programming languages and which compilers are better than others. We'll be getting to that in a separate live stream, one held towards the end of this week, a more technical live stream. But for now, thank you very much, Ritika, for joining in.
Thank you.
Thank you very much, everybody. Goodbye.